Good evening to all. Good evening to all. Yesterday I closed the session with Gauss divergence theorem statement. I hope that you are all prepared. What we discussed, the vector definitions, operator, line integral, formulas, results, problems. Now we are continuing that yesterday's statement with one or two problems followed by Stokes theorem. Then we will wind up this vector calculus. After that we will start today only complex variables. First problem, which is given 2011, 2 marks. Consider a closed surface S surrounding volume V full stop. If R bar is the position vector of a point inside S, comma, with encron the unit normal on S, comma, the value of the integral double integral over a closed surface S, denoted by this symbol, 5 R bar dot encron ds is now just compare yesterday's Gauss divergence theorem, encron okay, ds okay, integral over S, which is also given like this, double integral over S. Yesterday I have given different notations. Instead of f bar, which is here 5 R bar. Okay. Solution. By Gauss divergence theorem, GDT stands for Gauss divergence theorem, double integral over S, that is surface integral over S, 5 R bar dot encron ds. Just I am comparing what I highlight, what I underline the term by yesterday's notation f bar dot n bar ds. This is nothing but integral over V. Dive integral over V means it is a volume integral, triple integral only. Dive f bar dv. Okay. So what is f bar here? 5 R bar. That means I can write here dive of 5 R bar dot, I mean no dot, directly dv. Okay. So using that, yesterday I have given vector identities, dive 5 f bar, curl 5 f bar. This is going to simplify, this is going to 5 times integral over V dive R bar dv. And the same what I underlined here, dive R bar, yesterday I have given. So that is the advantage of that yesterday's result, what I given. So this is 5 times dive R bar means how much? 3. This is equal to 5 times integral over V 3 dv. So this is 15 times integral dv is nothing but V. What is V? Where V is the volume of S. Volume of the surface, yes. You can write here 15 where V is the volume of the surface. Yes. Since div phi f bar is equal to 5 div f bar, yesterday I have given this result, plus grad phi dot f bar. Here f bar is nothing but r bar. Comparing this identity, phi is nothing but phi. Gradient of a constant is 0. That's why this simplifies to phi times div r bar. See here, volume of S means volume of the body surrounding by the surfaces. Okay. Volume of a body whose surrounding is the surface. Yes, that is the meaning, volume of S. Another example which is given 2012, 2 marks. Evaluate integral over S a square x square plus b square y square plus c square z square raised to minus 1 over 2, comma, where S is the surface of the ellipsoid. S is the surface of the ellipsoid. Ax square plus by square plus cz square is equal to 1. Just see, this is whole to the power minus 1 over 2, minus 1 by 2. Minus 1 by 2. And this is ds. Solution. Comparing with Gauss-Stefan's theorem, this term, the term going to integrable is nothing but f bar dot n bar. F bar dot n bar is equal to a square x square plus b square y square plus c square z square whole to the power minus 1 by 2. Let phi is equal to, assign the, that means denote the given surface after bringing into one side by phi. Ax square by square plus cz square minus 1 is equal to 0. Why I am taking like this? Because we don't know f bar and we don't know n bar, but we know the procedure for finding n bar, grad phi by mod grad phi. Then from this dot product, according to this integral, I can assume or I can take f bar. Okay. Or you can write here, okay, f bar dot n bar, comparing with the statement. So del phi, that is gradient phi, I bar dou phi by dou x, that is 2ax plus j bar partial derivative with respect to y, 2ay plus k bar partial derivative with respect to z 2cz. Okay. N bar is equal to del phi by mod del phi. So in the length of the del phi modulus 2 square 4 is getting out, that is 4 from root becomes 2, and that 2 cancel with here, common 2 is there, so I can write directly ax I bar plus by, sorry here 2by, this is 2by, okay, by j bar cz k bar divided by square root of a square of a square x square plus b square y square plus c square z square. Now comparing the given integrand term here, we got like this 1 over square root. Then how to eliminate, so that we will be, after selecting properly f bar, then that f bar dot n bar is the value, this is the value nothing but the given integrand term, that is 1 over root a square x square plus b square y square plus c square z square. Okay. So choose f bar is equal to xi bar yj bar plus zk bar. So why I am choosing like this? If this f bar what I took dot with this n bar, you will be getting ax square by square cz square, that is nothing but from the surface equation it is 1. So finally this f bar dot n bar what we obtained, which is nothing but the given f bar dot n bar, that is the given integrand, okay, which implies f bar dot n bar is equal to ax square, that is this n bar dot with assumed vector, that is chosen f bar, by square plus cz square divided by square root of a square x square plus b square y square plus c square z square. The numerator is nothing but from the surface equation it is 1 over root over a square x square plus b square y square plus c square z square. Okay. Therefore, by Gauss divergence theorem, integral over S a square x square b square y square c square z square whole to the power minus 1 by 2 ds, this entire quantity is already denoted f bar dot n bar is equal to integral over v div f bar dv is equal to integral over v. What is div f bar? For this selected f bar, what is divergence? Nothing but 1 plus it is in the form of div r bar. You can compare like that also, dv. So integral 3 into v, that is v. What is v? Where v is the volume of, ellipsoid. Ellipsoid. What is ellipsoid equation? Ax square plus by square plus cz square is equal to 1. That is, it can be written in the form of x square by 1 over root a whole square plus y square by 1 over root b whole square plus z square by 1 over root c whole square. That means I have written the given ellipsoid into the standard form. Ellipse is a two-dimensional quantity. The extension to z, that is three-dimensional, it becomes ellipsoid. X square by a square plus y square by b square plus z square by c square is equal to 1. Okay. So due to that only I have made, I made this ellipsoid like this. Now what is volume of the ellipsoid? So this is equal to 3 times, just like volume of the sphere is 4 by 3 into r into r into r cube. Now instead of r cube it is giving 4 pi by 3 abc. Okay, by comparing with the standard ellipsoid equation, x square by a square plus y square by b square plus z square by c square is equal to 1. So 4 pi by 3 into 1 over root a, 1 over root b, 1 over root c. So this simplifies to 4 pi by root abc. This is the answer. First compare the given integrand with f bar dot n bar, then find n bar after taking your surface, bringing all the terms to one side, surface equation denoted by phi, then find grad phi by mod grad phi, and then after obtained n bar, properly choose f bar so that f bar dot n bar is nothing but the given integrand term. Then apply Gauss-Davis theorem, and you remember ellipsoid standard equation, volume of a sphere is 4 by 3 pi r cube, volume of the ellipsoid is 4 pi by 3 abc. So one problem I am giving you, later you do. So in this, due to this type of problems, you should remember mensuration formulas: volume of a cylinder, volume of a cone, volume of a parallelepiped, volume of a rectangular parallelepiped, volume of a cube, all these things. In areas, rectangle, square, circle, ellipse, like that. Here also volumes, three-dimensional one. Third one, (1993). Given V bar is equal to x cos square y I bar plus x square e power x j bar plus z sin square y k bar and S is the surface of a unit cube with one corner at the origin and edges parallel to the coordinate axis, comma, the value of the integral double integral over S, that is surface integral V bar dot n bar ds is Here unit cube means all the sides are equal to length 1. One vertex is origin, corner, all other sides edges parallel to coordinate x, x, y, x, z, x. So what is the volume of a cube? Length into breadth into height. That is x cube, where x is nothing but length of each side. Each side, all sides are equal, then only it is called cube. Okay. The 6 walls of a room, like cube, cuboid, all the faces rectangles, cuboid, all the faces squares. The 6 walls, that means these are 4 walls and ground floor and top floor, including, that is 6 walls, treated to be a 3D solid. These are 3 standard types: all faces parallelograms, all faces rectangles, all faces squares. Then it is, whenever all faces square, then it is a cube. Volume of a cube is length of the side cube. Okay, that is x cube, where length is given 1. So answer is, here I am giving using Gauss-Divergence theorem only. Answer 1. Next, Stokes theorem. Let S be an open surface, two-sided surface, bounded by a simple closed curve C, simple closed curve C, then and f bar is a differentiable vector function then integral over C. Statement is many times came, Stokes theorem. F bar dot dr bar is equal to integral over S curl f bar dot n bar ds, where n bar is the unit outward normal to S and C is traversed in positive direction, that is counterclockwise direction or anti-clockwise direction. The same integral S is also denoted by double integral over S, and instead of dot n bar it may give curl f bar dot ds bar, which I have given already yesterday, Gauss-Divergence theorem. Statement many times came. So this is the relationship between line integral and surface integral. Yesterday Gauss-Divergence theorem, relationship between surface integral and volume integral. another form of Gauss divergence theorem, GDT, full form Gauss divergence theorem. Double integral over S f1 dy dz plus f2 dz dx plus f3 dx dy is equal to triple integral over v del f1 by del x, that is dou f1 by dou x, dou f2 by dou y, partial derivative with respect to y, dou f3 by dou z, dx dy dz. So this is nothing but the evaluation of div f bar. Integral over v means triple integral only. Just same, nothing anything here. But only the difference is here, left side is expressed without, that means is a scalar form, no vector and no dot product, no n bar. Just compare yesterday's statement, which was given in simplified form. F bar dot n bar along with ds, this is simplified to here, like this. So surface integral, volume integral. This is the simplified form of yesterday's left side f bar dot n bar with ds. This is the simplified form of yesterday's right side div f bar. dv is nothing but dx dy dz. Stokes theorem is very important in the statement purpose, many times given in all the branches. So I am going to start very soon, that is in few seconds. Complex variables unit, last unit of this Max 2 paper. Complex variables. So first I will start with what we have studied, complex numbers in 11th standard, that is last chapter of trigonometry, +1 level, because sometimes the questions asked in previous gate question problems on that basics what we have studied in complex numbers in 11th standard. Okay, first 20 to half an hour, then I will go to our regular topic, complex variables. Okay, z is equal to x plus iy. To define a complex variable, first we take two real variables x and y. One is x axis, other is y imaginary axis. I is equal to root over -1. Okay, the plane so formed by real numbers, real axis, x axis, y axis, imaginary axis, is called orgone plane or complex plane. Okay, I is equal to root over -1. I value is called a complex number. So to define a complex number, we should need 2D. One is real axis, other is y axis. Similarly, to define a complex variable, we have to take 4 axes, coordinate axis. It is impossible. 3D diagrams only, it is difficult to visualize, understand or visualize. Okay, 4-dimensional axis, it is difficult to imagine. Okay, so in such cases, it was divided into 2D axis, x-axis, y-axis, 2D plane, another 2 axis represented by another 2D plane, that is u comma v axis, that we will come later, is called a complex number. Z bar is equal to x minus iy is the complex conjugate of z is equal to x plus iy. X is called real part of z, y is called imaginary part of z. X is equal to r of z, which is also can be written as z plus z bar by 2, and y is equal to I of z. I of z means imaginary part of z. So this is also can be written as, with the help of z and z bar, z minus z bar by 2i. Okay. Just I am recalling what we have studied in 11th standard, basics, formulas, all these things. I square minus 1, I cube minus I power 4, 1, 1 over I is equal to minus I. Next, z is equal to x plus iy is equal to r into cos theta plus I sin theta. This cos theta plus I sin theta is also represented as exponential I theta, Euler's transformation, is called polar form or modulo amplitude form. Where r is equal to root over x square plus y square is modulus of the given complex number, and theta is equal to tan inverse y by x. Is called amplitude of z. The value of theta lying between minus pi and pi is called principal value. So expressing the given complex number in terms of polar coordinate, that is polar form, r into cos theta plus I sin theta, where r is the modulus of z, theta is called amplitude of z. These things we have studied in 11th standard. The value of theta lying between minus pi and pi is called principal value. That means while solving these type of problems, expressing given complex number in terms of r comma theta, you may get theta many answers. That is called general value of theta. Whenever a value lying between minus pi to pi, that value is called principal value. That is also obtained by putting n is equal to 0. I will show you once we express in terms of general value and then putting or taking n is equal to 0 to get that principal value. So just verify here, x is equal to r. R stands for real part of z. This is equal to z plus z bar by 2. So what is this meaning? Real part of the given complex number z. And what is I of z meaning? Imaginary part of z. Next, nth roots of a complex number and here also you remember cos theta plus, just write somewhere or continuing the previous point, is equal to, this is called de Moivre's theorem, cos n theta plus I sin n theta. All these came from trigonometry 11th standard, last chapter of trigonometry, complex numbers. That is, the power n goes into the angle, multiplies the given angle. Let z is equal to x plus iy be a complex number. So this is hypothesis. You need to find two steps. Step 1, write z is equal to x plus iy is equal to polar form, that is r into cos theta plus I sin theta. This is a step 1. Okay, and this can be written as r into cos theta plus 2k pi plus I sin theta plus 2k pi, where k is an integer. Because whenever we know cos theta, sin theta value, theta is some angle, then for that angle, if you add multiples of 2 pi or subtract multiples of 2 pi, that is 2 pi, 4 pi, minus 2 pi, minus 4 pi, again it comes into the same position. That is, 2 pi means it is complete circle, completes one cycle. One cycle means that is complete angle is equal to 360 degrees. Similarly, 2 into 2 pi means 2 cycles, 2 complete cycles. Okay, so that means 2 into 360, all these again nothing but cos theta only. Cos 360 plus theta, cos 720 plus theta, similarly sin 360 plus theta gives cos theta as well as sin theta only. So this is step 1. Step 2 means, that is, what is the heading here I have given? Nth roots. Nth roots means first of all starts with square roots. Square roots means 2 values for the given complex number. Cube roots of a given number means it has 3 answers, 3 roots. Like that, nth roots of a given number means that z has n values. Okay. Z power 1 by n. On both sides of step 1 apply or raise to 1 over n. This becomes r power 1 by n into cos theta plus 2k pi divided by n. Why? Before that I have given using this formula, the power multiplies to the angle. So this is plus I sin theta plus 2k pi by n. Here remember, k values starts with 0, ends with 1 less from the given n, that is n minus 1. So this step is very very important. Step 1 is first express in terms of r and theta, that is r into cos theta plus I sin theta. Add the general term, that is multiples of 2 pi, that is 2k pi. Then taking both sides 1 over n, because we are going to find nth roots of a given complex number. So this is the result. Giving 1 by 1 value to k starts from 0 ends at n minus 1. You will be getting 1 by 1 values of the z over 1 by n, that is z raised to 1 over n. So first problem is Example 1. (2013) square roots of minus I, where I is equal to root over minus 1 are options A, I comma minus I, option B, cis minus pi by 4, comma cis 3 pi by 4. Here cis stands for first C letter cos, second letter I imaginary, third letter S stands for sin. Cos plus I sin simply written as cis. Option C, cos pi by 4 plus I sin 3 pi by 4, comma cos 3 pi by 4 plus I sin pi by 4. Option D, cos 3 pi by 4 plus I sin minus 3 pi by 4, comma cos minus 3 pi by 4 plus I sin 3 pi by 4. So before this I have given one result, De Moivre's theorem, cos theta plus I sin theta. Okay, this is nothing but cis theta. This can be written as cos theta plus I sin theta. I sin theta can be written as simple notation, simple form cis theta. Is equal to solution. Here, which is the complex number given? Minus I. Let us denote by Z and comparing with x comma y, bring into r comma theta. Properly you find r value, theta value, what I gave the before this problem what I gave that introduction, that 1, 2, 3, 4 points I have given. Here Z is equal to minus I. This is nothing but x plus iy is equal to r into cos theta plus I sin theta. Okay, so here r cos theta is equal to real part x which is absent, r sin theta is equal to imaginary part coefficient, that is minus 1, r is equal to root over x square plus 1 square, that is 1. So that cos theta, substitute r value here, don't apply directly. In some problems it is useful, theta value tan inverse y by x, but in some other problems we may get confusion to find that theta lies in first or second, third quadrant. Deciding that theta in which quadrant, it's sometimes little bit difficult. So that's why this is the unique procedure. After finding r, substitute here, you will be getting cos and sin. Then we can easily decide the quadrant, that is where theta lies. Sin theta minus 1, cos theta 0, that is theta is equal to how much? 3 pi by 2. Sin 270 minus 1, cos 270 degrees 0. Okay, so therefore Z is nothing but minus I is nothing but r value 1, I am not multiplying, cos 3 pi by 2 plus, without this procedure also, if you are well about cos 3 pi by 2, cos 2 pi, sin 15 degrees, all these things, sin 30, cos 60, you can write directly like this, not required to do. But this is the procedure fixed for all the problems of this type. Okay. Next, what I told in the first step, after finding theta, add multiples of 2 pi, 3 pi by 2 plus 2k pi plus I times sine of 3 pi by 2 plus 2k pi. Then taking both sides 1 over n, here 1 over n is nothing but nth roots. Here in this problem square root stand for 1 over 2. So therefore z raised to 1 over 2, that is minus I whole power 1 by 2, that is cos 3 pi by 4 plus 2k pi divided by half, that is k pi plus I times sine 3 pi by 4 plus k pi. Just using that cos theta plus I sin theta whole power n is equal to that formula. That power enters into the angle and then multiplies. What are k values? Where, because square roots, that means n is equal to 2, so k is equal to 0 comma 1. Here 1 is nothing but last value of k, that what I gave in that result, n minus 1. So giving k is equal to 1 by 1 and see that options. K is equal to 0 implies square root of minus I is equal to cos 3 pi by 4 plus I sin 3 pi by 4. 3 into 45 degrees 135 belongs to second quadrant. Cos gives negative, sin gives positive, and cos 45 degrees 1 over root 2, sin 45 degrees 1 over root 2. So this is not required to find these values because answers given in the form of cos and sin. So any answer cos 3 by 2, yes, cis 3 by 4 is there. Okay, now you find other value also. That means k is equal to 1, which implies root over minus I is equal to cos pi plus 3 pi by 4 simplifies to 7 pi by 4 plus I sin 7 pi by 4. 7 into 45 degrees, that is 350 degrees, 315 degrees located in fourth quadrant. It is in anti-clockwise direction. When it goes to clockwise direction, so subtract 45 degrees from 0 degrees, it will locate the same position 3 into pi by 7 into pi by 4, that is 315 degrees. So this can be written as cos minus pi by 4 plus I sin minus pi by 4. Because 7 into 45 degrees is nothing but minus 45 degrees. Just go to your 2D axis and plot that 0, 90 degrees, 270, 315 degrees, and in reverse way minus 45 degrees. Okay. So this is nothing but cis minus pi by 4, and this can be written as cis 3 pi by 4. This is the answer. So using this model, I am giving you one more gate question problem. If possible with answer, later you do. Second one. (2009)